Hello friends, myself Dattashree Jadhav. I am from HM College. In today's video, we are going to discuss fundamental theorem on integral calculus from the chapter definite integration and its properties. So first look at here, fundamental theorem on integral calculus. Let f be a continuous function defined on closed interval a comma b, and if integration of f of x dx, indefinite integration of f of x is equal to phi of x plus c, then they are said that integral of a to b f of x dx, that is definite integration of the function f of x over the interval a comma b, is equal to, look at here, integration of f of x is phi of x plus c. So integration of f of x dx is also phi of x plus c, and write its lower limit and upper limit. A is called as lower limit of the integration, b is called as upper limit of the integration to the square bracket, which is equal to, this is called as phi of x plus c is called as primitive, and which is equal to value of the primitive at upper limit, that is b. Put the value of x is b, so phi of b plus replace x by b minus value of the primitive at lower limit, that is a, replace x by a, so phi of a plus, which is equal to phi of b plus c minus phi of a minus plus c minus c get cancelled, which is equal to phi of b minus phi of a, value of the primitive at upper limit minus value of the primitive at lower limit, that is integration a to b f of x dx, that is definite integration of f of x dx over closed interval a comma b is equal to value of the primitive at upper limit minus value of the primitive at lower limit. It's a fundamental theorem on integral calculus, and theorem is without proof. So integral a to b f of x dx is equal to phi of b minus phi of a. Now moving to our next point. The next point is properties of definite integration. Properties of definite integration. Here in definite integration, the term of constant is not appear. It vanishes, plus c minus c vanishes. First look at here, properties of definite integration. There are 8 properties for definite integration. First property is prove that integral a to a f of x dx is equal to 0. Integral a to a f of x dx is equal to 0. For example, I can say here integral is 7 to 7 x dx, which is equal to integral 7 to 7, lower limit and upper limits are same. Yes, integration of x is x square upon, and value of the primitive from lower limit 7 to upper limit 7, which is equal to value of the primitive at upper limit 7 square divided by 2 minus value of the primitive at lower limit, replace x by 7, so it's again 7 square divided by 2. 7 square 49 divided by 2 minus 49 divided by 2, it's 0. So when upper limit and lower limit of the definite are same, then value of such integrations is always 0. Look at here. The proof of the property integral a to a f of x dx is equal to 0 is, first let integration of f of x dx, suppose integration of f of x dx is I say here g of x plus c. Integration of f of x dx is g of x, like integration of x raised to n is x raised to n plus 1 upon n plus 1 plus constant of integration c. So I can consider here integration of f of x is g of x plus c. Now LHS is equal to what is LHS is here integral a to a f of x dx. In mostly through that examples we take LHS and show RHS. So I can consider here LHS is equal to integral a to a f of x dx. But we know that integration of f of x dx, indefinite integration of f of x dx is equal to g of x plus c. So integration of f of x dx is g of x plus c, and put bracket for that primitive and write limits, lower limit and upper limit here. G of x plus c, value of the primitive from a to a, which is equal to value of the primitive at upper limit from fundamental theorem on integral calculus. Value of the primitive at upper limit means replace x by a, that is g of a plus minus value of the primitive at lower limit. Lower limit is a and primitive is g of x plus c. Put x is equal to a. So g of x plus, replace x by a, g of a plus is equal to g of a plus c minus g of a minus plus c minus c get cancelled, plus g of a minus g of a get cancelled, and which is nothing but RHS, which is equal to RHS. Hence we say that integral a to a f of x dx is equal to 0. Remember, if lower limit and upper limit of definite integrations are same, then answer of that definite integration is clearly 0. Now moving to our next property. Next property is prove that integral a to b f of x dx is equal to minus integral b to a f of x dx. Integral a to b f of x dx is equal to minus integral b to a f of x dx. In LHS, the limits of the integrations are a to b, and in RHS, the limits of the integrations from b to a. Means if we change lower limit and upper limit of definite integration, then value of definite integration changes by sign. If it is plus, then we get minus, and if it is minus, then we get plus. So proof of this property is, first let integration of, assume that integration of f of x dx is something a function means, so I can consider or let integration of f of x dx is equal to g of x plus, हे मानलेले आपण f of x चे इंटिग्रेशन काहीतरी येत असेल आणि ते x मधलं येईल असं मानले g of x plus c. जसं cos x चे इंटिग्रेशन हे sin x cos x चे इंटिग्रेशन काय तर sin x येतं, हे फंक्शन येतं x मधलं. तसं f हे x मधलं फंक्शन आहे, आता नवीन एक फंक्शन येईल त्याला मी g मागतोय. Now consider LHS is equal to here LHS is integral a to b f of x dx. Consider LHS or prove that. So LHS is equal to integral a to b f of x dx, which is equal to, but we know that integration of f of x dx is g of x plus c. So I can write this as g of x plus c. Put bracket there, square brackets, and write lower limit and upper limit after completing the bracket, which is equal to, from first or fundamental theorem on integral calculus, we calculate value of the primitive at upper limit minus value of the primitive at lower limit. Put the value of primitive at upper limit. This is primitive and it is value for x. So put x is equal to b. We get g of b plus c. Replace x by b. G of b plus c. C is constant. Minus value of the primitive at lower limit. Here lower limit is a. Put x is equal to a in the primitive. Primitive means what? G of x plus c. Put x is equal to a. It becomes g of a plus c, which is equal to g of b plus c minus g of a minus c. Plus c minus c get cancelled. It's g of b minus g of a. It's our equation number first. Now we consider RHS. Now RHS is equal to, what is RHS is here? Minus integral b to a f of x dx minus integral b to a f of x dx, which is equal to minus constant as it is integration of b to a f of x dx. Integration of b to a f of x dx. Definite integration is there, but we are considering or let integration of f of x dx is g of x plus c. So I can write the answer of this different integration is g of x plus c, since integration of f of x dx is g of x plus c, and value of the primitive from lower limit b to upper limit a. Put value of the lower primitive. Find the value of the primitive at upper limit minus value of the primitive at upper limit is what? G of b plus c. Replace x by upper limit. Sorry, here upper limit is a. So value of the primitive at upper limit is g of a plus c minus value of the primitive at lower limit. Lower limit is b. So put x by, replace x by b. So g of b plus is equal to, after simplification we can write this as g of a plus minus g of b minus plus c minus c get cancelled, minus inside the bracket it's g of a minus g of b. Taking minus sign inside the bracket, therefore we get negative becomes positive and positive becomes negative. G of b minus g of a, which is equation number second. Look at here, equation first and equation second. In equation first, RHS is g of b minus g of a. In equation second, RHS is g of b minus g of a. In both the equations, RHS are same. RHS are same. So its LHS are same. That is, LHS is equal to RHS. From equation first and equation second, we say that LHS is equal to RHS. But what is LHS? LHS is integral a to b f of x dx. Integral a to b f of x dx, which is equal to RHS is what? Minus integral b to a f of x dx. Remember, if we change the limits of definite integration, value of the definite integration by changes one sign. If it is plus, then we get minus, and if it is minus, then we get plus. For example, take one example is here. For example, integration 2 to 3 e raised to x dx is equal to integration of 2 to 3 e raised to x dx is equal to, we know that the integration of e raised to x is e raised to x, so its primitive is e raised to x, and value of the primitive from lower limit 2 to upper limit 3 is equal to value of the primitive at upper limit, that is replace x by 3 e raised to 3 minus value of 3, it's called as primitive, and value of the primitive at lower limit is 2, so it's e raised to 2 replace x by 2 in primitive, so integration 2 to 3 e raised to x dx is equal to e cube minus e square. Now I can change here lower limits and upper limits, that is integration from 3 to 2 e raised to x dx. What happened here? Which is equal to, yes, integration of e raised to x dx is e raised to x, so I can write e raised to x, value of the primitive from 3 to 2, value of the primitive at upper limit, yes, replace x by 2, so e raised to 2 minus value of the primitive at lower limit e raised to 3. But look at the answers, e raised to 3 minus e square, and here e square minus e raised to 3, we check minus integral 3 to 2 e raised to x dx. Take minus, write minus sign here, write minus sign here, and after simplification we get e raised to 3, negative becomes positive and positive becomes negative, e raised to 3 minus e square. So if we change the lower limit and upper limit of definite integration, then value of the definite integration changes by sign. Okay, so if there is no minus sign, then what happens? It's taking minus sign common, e cube minus e square, that is minus integral 2 to 3, e cube minus e square is integral 2 to 3 e raised to x dx. So if we change lower limit and upper limit of the integration, then value of that definite integration changes by sign. Now third property is prove that integration of a to b f of x dx, integration of a to b f of x dx is equal to integral a to b f of t dt. Integral a to b f of t dt means if here the integration variable of the integration is x, and here variable of the integration is t. In definite integration, if we replace any variable by another variable, then value of the integration is same. For example, consider integration of 2 to 3, definite integration of 2 to 3 e raised to x dx, which is equal to, we know that integration of e raised to x is e raised to x, So integration of e raised to x dx is e raised to x. Don't write c. In definite integration, the c is vanishes. Value of the primitive from, it is called as primitive, 2 to 3. Value of the primitive at upper limit, that is e raised to 3, minus value of the primitive at lower limit, that is e raised to 2. Now check another example. Integration 2 to 3 e raised to t dt, which is equal to, we are changing the variable x by t, then what happens? So integration of e raised to t is e raised to t, value of the primitive from 2 to 3, value of the primitive at upper limit e raised to 3 minus value of the primitive at lower limit, that is e raised to 2. From equation first and second, we see that RHS are same, so LHS are also same. If we change the variable, in definite integration, then value of definite integration remains same. Value of definite integration remains same. First, let integration of f of x dx. I can consider that integration of f of x dx is g of x plus c. Integration of f of x dx is equal to g of x plus c. Example or property is on through that. So taking LHS, consider LHS is equal to, what is LHS is here? Into that LHS is integral a to b f of x dx, integral a to b f of x dx. But we know that integration of f of x dx is g of x plus c. So integration of f of x dx is g of x plus c. Indefinite integration is g of x plus c, and for definite integration it's g of x plus c. But write limits is from a to b, where a is lower limit and b is upper limit. Put value of the primitive x by b, value of the primitive upper limit b, so it becomes g of b plus c minus value of the primitive at upper limit is there, value of the primitive at lower limit. Lower limit is what? It's g of a plus c is equal to g of b plus c minus g of a minus c plus c minus c get cancelled. It's g of b minus g of a. It's our equation number first. LHS is equal to g of b minus g of a. Now considering RHS. RHS is what? Integral a to b f of t dt. Integration of a to b f of t dt. Now we know that integration of f of x dx is g of x plus c. If we replace x by t, then integration of f of t dt is equal to g of t plus c. So tell me integration of f of t dt. It's g of t plus c. So I can write it's g of t plus c, and value of the primitive from a to b. Value of the primitive at upper limit, that is put the value of t is b, g of t plus c minus value of the primitive at lower limit. Fundamental principle of integral calculation or fundamental theorem of integral calculus. Value of the primitive at lower limit. Lower limit is a, so g of a plus c. After simplification we get g of t plus c minus g of a minus c plus c minus value of the primitive at upper limit, that is b, replace t by b, g of b plus c minus g of a plus c. It's g of b plus c minus g of a minus c plus c minus c get cancelled. It's g of b minus g of a. It's equation number second. From equation first and equation number second, RHS of both the equations are same, so LHS are same. Therefore, from equation first and equation second, we see that LHS is equal to RHS. But what is LHS? LHS is integral a to b f of x dx, integral a to b f of x dx, and RHS is what? Integral a to b f of t dt. Integral a to b f of t dt. So hence the proof. Now the last property is prove that integral a to b f of x dx. Prove that integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx, where c is lies in between a and b, or c belongs to the interval a comma b. If there is a number in between a and b, that is c, then we write a single integration in two integrations, single definite integration in two definite integrations. First, we prove that property, and taking one example. To prove this property, I assume that integration of f of x dx is equal to phi of x plus indefinite integration of f of x is phi of x. Consider LHS is equal to, here LHS is what? Integral a to b f of x dx. But integration of a to b f of x dx is phi of x plus c, which is equal to phi of x plus value of the primitive from lower limit a to upper limit b. Lower limit a to upper limit b. Phi of x plus c is called as primitive. Now find the value of the primitive at upper limit, which is equal to phi of b plus c. Value of the primitive at upper limit, replace x by b, minus value of the primitive at lower limit. Put x is equal to a, so phi of a plus. After simplification, we write this as phi of b plus c minus phi of a minus c. Plus c minus c get cancelled. It's phi of b minus phi of a. It's our equation number first. Now we consider RHS. What is RHS is here? RHS is integral a to c f of x dx. Integral a to c f of x dx plus integral c to b f of x dx, where c is lies in between a to b. C is a number which is lies in between a to b, is equal to, we know that integration of f of x dx is phi of x plus c. So I can write here phi of x plus c, value of the primitive from a to c, plus again integral c to b f of x dx. Integration of f of x dx is phi of x plus value of the primitive from c to b is equal to, after evaluation, value of the primitive upper limit is c. Here c is there, so I can write instead of c I can write instead of C it's K. Value of the primitive at upper limit. So we get phi of C plus K minus value of the primitive at lower limit. Lower limit is a phi of A plus K plus for second primitive value of the primitive at upper limit phi of B plus K minus value of the primitive at lower limit. Lower limit is what? C. Phi of C plus K. After simplification I can write phi of C plus K minus phi of A minus K plus phi of B plus K minus phi of C minus K plus K minus K plus K minus K get cancelled, and what happened? Plus phi of C minus phi of C get cancelled. What's remaining here? Phi of B minus phi of A. From which is our equation number second? From equation first and equation second, RHS of both the equations are same. Hence we say that from equation first and equation second, we say that LHS is equal to RHS. LHS is equal to RHS. Therefore, what is LHS? Integral A to B f of x dx, which is equal to integral A to B, A to new number C f of x dx plus integral C to B f of x dx. Hence the proof. So students, remember here fourth property says that if there is a single integration or definite integration, then we convert or we write that single integration into definite integration. But we are using that property from right to left. If there are two integrations, definite integrations, and functions are same, then we write in single integration. For example, integral 0 to 4 of x dx is equal to integral 0 to 4 of x dx is equal to, yes, integration of x is x square divided by value of the primitive from 0 to 4. Here lower limit is 0, upper limit is 4, which is equal to 4 square divided by minus 0 square divided by, this is primitive, replace x by 4, value of the primitive at upper limit, so 4 square by 2 minus value of the primitive at lower limit 0 square by 2, 4 square by 2, 4 square 16 by 2 is 8 minus 0 by 2, 0 square is 0, 0 by 2 is 0, so it's 8. Now I can write this single integration 0 to 4 x dx in two integrations. Clearly tell me, 2 is lies in between 0 and 4. 2 is lies in between 0 and 4. So I can write integral 0 to 4 x dx as 0 to 2 x dx plus integral 2 to 4 x dx. I can write that single integration in addition of two integrations is equal to integration of x dx is x square by 2, value of the primitive from 0 to 2, plus integration of x dx is x square by 2, value of the primitive from 2 to 4 is equal to. Now evaluate value of the primitive at upper limit 2 square divided by 2 minus value of the primitive at lower limit 0 square divided by 2 plus value of the primitive at upper limit 4 square divided by 2 minus value of the primitive at lower limit 2 square square divided by 2 plus 2 square divided by 2 minus 2 square divided by 2 get cancelled. 0 square divided by 2 is 0 and 4 square 16 divided by 2 is 8. So look at these two equations. RHS are same, means if there is a single integration, then we write that single integration in two different integrations. Or if there are two different integrations, then we write that two different integrations as a single integration continuously from 0 to 4. Here 0 to 2 and 2 to 4. So directly we write 0 to 4 f of x dx. So students, in this video we learn about fundamental theorem on integral calculus and 4 properties on definite integration from the chapter definite integration. I hope you understood the properties of definite integration very well. Thank you for watching the video.